and it's just steps and skills, and this is a bit of substitution. So just letting you know that we're all being recorded. So here we've got this question. You've got a large tank in the shape of a cuboid. It is made from 54 meters squared of sheet metal. Meters squared, that's area, so that's surface area of the metal. And the tank has a horizontal base and no top. The height of the tank is x meters, and two of the opposite vertical faces are squares. Show that the volume V meters cubed of the tank is given by this formula here. And this is all like substitution, which is helpful for mechanics and all other topics as well. And B is, given that x can vary, use differentiation to find the maximum minimum value of V. So we'll go back to that. Now I'm going to show you like this. Same question. Surface area equals 54, and then we can find the surface area of this cuboid with no top by just using our algebra. So the volume equals this x squared times y, because we need a volume. That's our first formula here, because we're trying to find volumes. We need to create a formula for volume. So we've got this terms in x squared and y. So like in mechanics, when we've got two terms we don't know, we have to use another bit of information in the question, which is this, 54 meters squared. So we can find surface area. Now I've just done the surface area here for you. I think I've jumped a bit. So the surface area of this is going to be, if you have a look, is my pen working? Okay, so we've got x squared here, and that's 2x squared for that side and this side. Now can we see we've got plus xy, which gives us this, and we've got 3 lots of xy. That's the front, back and bottom, and we know that equals 54. Now this term is all in x's, so we need to make what the subject in this question. What do we need to do to make the subject? And we know it is y, right? So we're making y the subject. We're going to do minus 2x squared on both sides. So we get 3xy equals 54 minus 2x squared. We want y to be the subject, so that's why we divide out by 3x. And we get this. Now that we've got y in terms of x, we can substitute this into here. Ooh, why has that disappeared? Okay. So replace y, that becomes like so, and we expand that out. Now you can see if we divide each term here by 3x, we will get 18x. But I will do this all in one go, because 3x divided by 54x squared is going to give us 18x. And then we've shown that. Are we happy with that so far? Yep, thank you, Nia. So we're almost there. Now, that's part A done, a few marks. And if you're not sure, you can start something off, earn some method marks. So that's part A done. Find the maximum volume of the tank. Now, I'm just going to show you the equation for the volume. This is the equation of the graph. So the maximum volume, you can see, is right there. So in terms of gradient, what is the gradient of this line here? 0, it is, because it's that which gives us what we call a local maximum. So, and that's the gradient, m equals 0. Now the gradient function we know is dy dx, but this is in terms of dv dx, so we find dv dx is volume in respect to x. And that makes sense. The maximum volume will be at what we call the stationary point as well. Hence the gradient will equal 0. So we just need to differentiate it and say it equal to 0. So the dv dx of that is going to be 18 times the power and decrease the power by 1. We set that to 0 because the gradient is going to be 0 at the local maximum. And we solve for x. Now we're going to get two values, plus or minus 3, but we know it must be 3 because x is a length. Now to find the maximum volume of the tank, once we've got x equals 3, that's the maximum volume, we just substitute the 3 back into v to get the maximum volume. And are we happy with that, people? So that's just building up your skills. And the last example I showed you, which was like a 10-mark question, which will, if you notice that actually is going to increase your mark by a whole grade. Are we okay? Leah, Tiana, Maggie, Emily, Caitlin, are we okay? Yay or nay? Or do you need me to go over a certain part? And if it's easier, you can speak on the mic or just type.
I'm okay.
Oh, fine. Thank you, Naya.
I'm alright.
Thank you, Tiana. That's a lot easier. Okay, so we're going to step it up. I've chosen this question, and it's an old exam question. And you know the questions you get these days are slightly more difficult, but it still practices all your skills and substitution. There's an exam question here, very similar, but you've just got 2x and give that a go. And if you need to start off, you're going to find what's the volume in terms of x. Actually, I'm going to show you the mark scheme for speed so you get the idea. Because you might have come unstuck there, we don't know what this is. We don't know what this is, so we can just call that y. So that's the, let's do that dotted line there. That will be the cross section. So we've got your xy there times 2x. So v equals xy times 2x, which gives us 2x squared y, and we know the volume equals 81. Now let's get the length. So our next volume is the length. Next formula is our length. Now you can see we've got a 2x here, which gives us here. Got a 2x this side, that's 2. That's the second one. We've got x here and x here, which gives us this x and this x. And obviously you've got that all on the back side as well. So let's just combine that. That's why we've got 2 times 6x. That's where we get it from. And then we can see we've got one y here, another y here, another y here, and another y at the back. And that's why we get the plus 4y. And that becomes L equals 12x plus 4y. Now, again, see we've got terms in x, so the key is to substitute and rearrange this in terms of y. I mean this one in terms of y, because we've got a figure here. So we can see we've got y equals 81 over 2x squared. So we substitute this into our nice formula over here. So we get L equals, and we can see our 12x up here, plus 4, 81 over 2x squared. And when you simplify all this, you do get that. That's a nice easy 3 marks. So B, it says use calculus to find the minimum value of L. So you still set your dy dx equals 0. But do it in terms of dl dx. So dl dx is going to equal 12. Now I'm going to rewrite this here as 12x plus 162x to the minus 2. So it's going to be 12 minus 2 times 162 is 324. X to the minus 3, I believe. Yep. Set that equal to 0. I'll probably plus the 324 this side. And this might be easier for you to work with if I write it like that. So we times both sides by x cubed. Divide by 12. And then cubic root. And we should get a value for x, which I'll let you do. What value do we get for x? Three. That's part B is x equals 3. Now, perfect. So you use, and it says use calculus to find the minimum value of L. So you can see up to there you've got your 4 marks. All doable. And you substitute the 3 into your formula for L, and you should get your final answer as 54. So what do you think we need to do for part C? Do you remember? Justify by further differentiation that the value of L that you have found is a minimum. Do you remember what we do? It does say further differentiation, so that is the clue. Can we remember what Ms. Anto taught you? Differentiate again, which is called a second derivative. Thank you, Maggie. You are correct. So differentiate your dl dx. So your notation will be d to l dx squared. Minus 3 times 3 to 4. It's going to change it to a plus. 972 x to minus 4. And what do we do next? We sub our value x equals 3 into this, and we'll get a positive value. And when the second derivative is positive, it's greater than 0. It's greater than 0, then it's a minimum. And hopefully if you remember, when it's less than 0, it's a maximum at that point. And that is that. Any questions about that one? And hopefully that's all coming back to you a little bit. You're good? Okay. Now we're just going to apply that skill. So that question I showed you last week, it's only slightly had one more tier of difficulty, but the skills you'll see was exactly the same. So I'm going to give you some questions. So 7 is just going to build up that skill. So a closed cylinder has this. Show that the volume V, centimeters cubed of this cylinder, is given by this formula, where R is the radius. Find the maximum volume of such a cylinder. So first step is, obviously you need a surface area for a cylinder. Which has radius R. And then create a formula for the volume of a cylinder. And see what you can do. If you have any questions about it, let me know. And let me just draw a cylinder for you to help you visualize the problem. Got a cylinder. Got radius R. And hopefully you can remember the surface area of a cylinder from your GCSEs. So which equals 600 pi is going to equal, we know that circle here is pi r squared. There's this at the bottom, so it's 2 pi r squared. And do we remember how to get this rectangle in front? It's a rectangle that wraps around it. Yes, well remembered. It is the circumference, so 2 pi r again, or pi d, but we want to keep our terms in r, so it's plus 2 pi r, and then we've got to label the length because it's an unknown. We don't know what it is, do we? So we could call that L or H, but I would not use L because it can look like a number sometimes and fire us off. So let's just call that H. We've got 2 pi r H. Now the volume is pi r squared H, right? That's the cross section by its height. So we've got this, we've got 600 pi equals 2 pi r squared plus 2 pi r H. And it says, show that the volume is given by this, so we can see what do we need. We need to get rid of H or make H the subject, so we can substitute here. So essentially you make H the subject here. Make H the subject. And then substitute it in and see if you get that, and then I'll let you guys finish that off. Find the maximum volume by differentiating it and setting it to 0. So hopefully we've got there and could show that V equals that when you substitute and make H the subject. So on this, H is essentially going to be, let's skip a step. You can get 2 pi r H is going to equal 2 pi r squared minus 600 pi. So H is going to equal divided by 2 pi r. And we simplify that, 2 pi r. So once you simplify that, 2 pi is going to cancel, you're going to get left with r. 2 pi divided by 600 pi is going to give you minus 300. And so volume equals pi r squared to h, r minus 300 over r. So that's going to give us pi r squared here. Pi r cubed. And I think I've written that the wrong way round. 600 2 pi r squared plus 2 pi r h. So 2 pi r h equals 600 pi minus 2 pi r. So let's cross that out. So that's a plus, that's a minus. So in fact we get minus r plus that. There, that's a quick fix. So that does give us pi r cubed here, which is a minus pi r cubed, and 300 times pi r squared. So we're going to get plus 300 pi, and r divided by r is going to leave us r, and just rewrite that neatly. It's exactly what we've got at the top, minus pi r cubed. Now, so we do dv in respect to r. Pi is just a constant as well, so we're going to get left with 300 pi minus 3 pi r squared. Set that to 0 and solve, and we'll get eventually r equals 10, because I'm going to run out of space. And then when you get r equals 10, just substitute r equals 10 into the volume formula, and you get the answer. All right, are we okay with that? And it's just lots of steps rearranging. Try not to be careless like me and try and jump a step. Well done, that's good. So hopefully you feel a bit better about those questions. Question 8 is exactly the same skill, but because we only got 25 minutes left, I didn't want to spend all my time on differentiation. I want us to try, oh, I've got another question to try, but that's fine. Which topic did I want to revise with you? Factorise completely. Did we do this the other week? I'm not sure we did it or not. When we factorise this, I mean, you could think use a factor theorem or divide it and see how it factorises. But you see, this was a nice one. There's an x in all the terms, so we can take x out. I've lost track of my pen. We take x out, and we're going to get x squared plus 10x plus 25. Now that can be factorised, and that's just going to be x plus 5, x plus 5, and we are done with the first 2 marks. Yeah, I don't think we did. I think I purposely got this question to do just because it's quite a long go and it's applying graph transformations. So we need to sketch the curve. So x plus 5, that means that's, just hope you can remember what I said. So that's the same as this, x plus 5 squared. So when you have a squared here, what does that mean? It's a what type of root? Only one, yeah, and we call that a repeated root. So that's when it just touches the axis in a way. That's a repeated root. So look at our solutions for sketching this. We've got x equals 0 and x equals minus 5. So we just need to sketch that curve. So where have I lost track of the pen? So now it crosses here, 0 and -5. So that's -5, that's all we need. Remember, our cubic looks like this. So how do you think the graph is going to be drawn? Because that's a positive cubic, and well, it can't go anywhere else really. It's going to go like that, and that will get you a 2 out of 2 marks. Now this is a big 3 marker. So can you see you've got the point of coordinate -3, 0 lies on the curve with this equation. So this is a new equation where it's got the a in, and it's very closely linked to this. So if this is f of x, right, what is this? This is f of x what? F of x plus a. Hopefully you can see that. Oh, actually there's a mistake here. So just in case you get confused, that is a squared. That's just a typo in the exam question. Just in case you're getting a bit confused with what was going on. So what does this mean when it's a translation like that? What's happening? Or transformation, I should say. Can you remember? Go on, Emily. You should know your graph transformations. What does that mean? When it's inside a bracket, which way is it going? X. Yep. It goes left or right. Now with this, when it's inside a bracket, we solve it, right? Now I'm just going to put -3, 0. -3, 0 is going to be here somewhere. So this original graph in the blue I've done is getting translated left or right somehow by A. So what can A be? Now I think you can't miss it, but you can see this graph can shift this way, so it becomes like this. Right, that comes something like that. So the other A, so if it's going left, that's 0, 0. If it's going left 3, then A equals +3. And you just need to spot that. Yes, perfect, Nia. Superstar there. And that's a good bonus 3 marks. And it's just applying your graph transformations in a harder to spot context. Right, number 2. Students sometimes get these types of questions wrong. And you've noticed most graphs, they get you to sketch some type of reciprocal or negative reciprocal. They don't normally give you a nice easy one. But what we do is we start off, what do we know a reciprocal graph look like? What does 1 over x look like? We know it's that, right? With isotopes, y equals 0 and x equals 0. Now here, we've got +1 on the outside, so we know it affects the y, so that's going up 1. And it just says here, sketch C stating the equation of the horizontal isotope. So we don't even need to worry about what K is. We just need to move something along. So we're moving this all up 1. This whole thing up 1. So that means if the asymptote, the horizontal line was y equals 0, then you're going to get that dotted line at 1. And so that's just going to be like this. And you can see that's just going to be like that. And that is your, how many marks is that? 3 marks. But we need to state this coordinate, I believe. But to solve that, I believe we just set y equals 0. Can we solve that? So 0 equals k squared over x plus 1. And we get minus 1 equals k squared over x. Times that by x. We're going to get minus x equals k squared. I say x equals minus k squared, and that's just going to be k squared. I'm not sure you actually need to write that, but just in case you get a question like that. Okay, let's go to B. Show that the x coordinate of any intersection of L with C is given by a solution of the equation. The line has L as this equation. So what is that saying? That's saying we've got an equation. Intersect is when they meet. I'll let you have a little think about that. That's going to do something like that. It's minus 2x, where that is 5. So how can we show that? When they intersect, what's going to happen? If this intersects with this, what are they going to be? If two equations intersect, what are they going to be? Seven marks. That's, these two could almost be worth a grade and a half, almost 2 grades. If this line intersects with this, what do we set the equations to? Yes, equal to each other. So that, if you just look at this, it looks really complicated. You've got the k squared here, you've got this line, you don't know what to do, but all literally say minus 2x plus 5 equals k squared x plus 1, and you just rearrange that all. So let's minus 1 on both sides. So we're going to get minus 2x plus 4 equals k squared over x. Multiply out by x, so that's going to be nice. We're going to get minus 2x squared plus 4x equals k squared. And you can see there's a positive k squared here. And you can see they brought both of these terms over to the other side. So we're going to get 0 equals k squared plus the 2x squared. And that's going to be minus 4x. And this is essentially the same as this. And that's the 2 marks that you've all got the knowledge to do. Just a bit of manipulation. Hence, find the exact values for k which L is a tangent to C. So if L is a tangent to C, let's readjust this and do a blue. This line is more like this. It's a tangent to C, so it just touches that there. Right? That's a tangent. What do we do? What can we do, people? Do we have an idea? Because once you unlock this, that 3 marks is achievable. Find the exact values for k for which L is a tangent to Z. Well, we've got to set this equation to, this is an equation set to 0. So, are we having any guesses? Because this could be a lost 3 marks. Any idea what to do here? I. Oh, not differentiate. Ah. Go on, you must be able to get the word now. To find solutions. Now, sometimes it says, you know, you can find 1, 2, or 0 solutions. Discriminant. Thank you, Caitlin. So we have our, this says equal, so we just use b squared minus 4ac equals 0. And if you've got, let's say exact values for k, so you've got a equals 2, b equals minus 4, c equals k squared. So b squared minus 4 squared is 16 minus 4 times a, which is 8, so it's minus 8k. Yeah, minus 8k squared equals 0. So we get 16 equals 8k squared. Divide out by 8. So you get 2 equals k squared. K equals plus or minus root 2. And it does say exact values, okay, so it's more than one value, okay. And that is how you do that one. And sometimes, so this setting to 0 and finding exact values, remember, I tried to emphasize that point quite a lot when I was doing this. You can use discriminant a lot to prove or find solutions to things. All right. Because, like you see, normally how can we solve this is if that wasn't the k squared, factorize, complete the square quadratic formula. But because we've got the k, we can use the b squared minus 4ac and find the values of k.